Good afternoon. I'm Mick Sculler. I want to welcome you to rear wheel steering.
My name's Andrew Zink. I'd like to welcome you to rear wheel steering as well.
Now, tell you what, first things first, what you need to have. Now, you have a participant guide. Can help you quite a bit here. There it is, rear wheel steering for Quadrasteer. And you can also see our course number in the corner there, 3041.20D. Definitely can help you out, kind of guide following along where I broadcast. It includes subject information, area to write down notes, diagnostic charts, exercises, as well as our course evaluation report. I'd like to have fill out at the end of our broadcast. Our CSI. So if you can give it there, sure would appreciate it. All right, now, the only place you can get that guide is out on the website, and that's mtraining.com. Go in there, log on to the site, click on resources, and then training materials, and finally, ideal participant guides.
Let's talk about our purpose for being here today, the course goal. Okay, course goal. Upon successful completion of this course, you will be able to identify the real steering system associated component, apply concepts and procedures to diagnose the system operation.
And the information and activities of the session will enable you to identify the real steering system and its benefits. Also identify system components, their roles in the operation of the system. Also identify some of the unique features of the system and show you a little bit about how to diagnose this rear wheel steer system.
All right, let's get started. Page 1-1 in your participant guide, okay? Take a look at what we're going to cover in this first module. We're going to talk about the benefits of rear wheel steering. We're going to talk about the 3 phases of operation you're going to see the system operate in. We're going to talk about the 3 modes that are driver selectable. And we're going to wrap up module number 1, that is, by talking about some cautions and things to keep in mind about lifting and jacking one of these Quadrasteer equipped vehicles. So first, with the system benefits. Now, you can imagine a vehicle equipped with rear wheel steering in addition to front wheel steering give us benefits and advantages for a typical vehicle with conventional front wheel steering. Now, some of these include a reduced turning radius or a smaller turning radius for that fact, increased stability during high-speed maneuvers, increased maneuverability when towing a trailer, and better maneuverability during low-speed maneuvers, much like parking lot maneuvers.
All right, well, let's go ahead and talk a little bit about that turning radius here. We've got a quick slide to show you. Again, just kind of highlights the differences. Okay, out here, this outer circle, that's our typical CK truck. In radius, quite simply, that's heading in rear wheel steering. So we have a reduced turning radius. It's a big benefit in turning this vehicle in tight circles. So parking lot maneuvers is definitely where it shows up. And it gets down to about 37 foot. Hey, that's pretty good. That's like a Saturn sedan, something like that. Okay? So in pretty good shape at that point, being able to maneuver that around and get into fairly tight spaces.
Now, let's take a look on page 1-2, your participant guide. And what we're going to talk about is the 3 phases that the system will operate in. The 3 phases are the negative, the neutral, and positive phase. We're going to talk about each one of them. Let's first focus on the negative phase. Take a look at the graphic on the screen. It's the same one you have in your book. Now, you see numbers up here. Hey, that's the speed range of the vehicle. This little line throughout our pretty graphic here, that's the movement of the rear wheels through the speed range of the vehicle. Now, let's talk about the negative phase. Here's the negative phase. Look at the direction of the rear wheels. They are turned in the opposite direction from front ones. We're also going to use negative phase at speeds of 45 miles an hour and slower, so right in that area. Okay, this is like our center line there, when the wheels are straight. So, turning the rear wheels in the opposite direction from the front, you can see that that's what gives us our tighter turning radius, or our smaller turning radius. Now, there's one number that isn't in your book that we want to share with you. It's 12 degrees. 12 degrees is the maximum amount of rear wheel movement that you'll see at the rear wheels in that negative phase. Well, now that we know about the negative phase, we have to speak about neutral.
All right, there it is, neutral phase. What's happening in the neutral phase? Well, we've got the rear wheels in the straight ahead position. Now, this is going to occur right around that 45-degree mark. So, like Andrew said, we've got 12 degrees in negative phase. Slowly, we're picking up speed, we're getting rid of that, get closer, closer till at this point right here, that's 0. That's the rear wheels in that straight ahead position. Not turning them at all. We're also using neutral phase anytime the system detects a problem. So if we see a problem with the system, no matter what's going on, the speed we're dealing with, it's going to go ahead with the rear wheels in the straight ahead position. So kind of a default position as well. Now next up, Andrew, take care of the positive phase.
Yeah, the last one of the 3 phases. And as you can see, now we turn the rear wheels in the same direction as the front ones. And we're using positive phase at speeds of 45 miles per hour or faster. Well, turning the rear wheels in the same direction as the fronts, if you can imagine, it can cause the vehicle to almost move laterally or move sideways when we're switching lanes. This is what gives us better maneuverability or stability at high speeds. Here's another number for you, 5 degrees. Maximum amount of rear wheel movement in the positive phase. So we don't have to turn them quite as far as we do in the negative phase, but then again, we're traveling at higher speeds, and through the engineering and the design of it, we just simply don't have to. It's a 5-degree maximum in that positive phase. Now let's do this. Better demonstrate and illustrate what we're talking about here with our different phases and a little bit on modes. Let's take a look at this next video.
The rear wheel steering system helps improve stability during high-speed lane changes. With the mode select switch in the four-wheel steer position, front and rear wheels turn in the same direction during high-speed maneuvers, such as lane changes. When both the front and rear wheels turn in the same direction, the system is operating in a positive phase. Positive phase rear wheel steering improves stability during higher speed maneuvers. The stability of rear wheel steering continues with the trailer attached. The system continues operating in positive phase. This allows the trailer to track the truck more directly. With rear wheel steering, backing and parking a trailer becomes easier, particularly when additional maneuvering space isn't available. When operating at slow speeds in the tow mode, the rear wheels turn the opposite direction of the front wheel. This allows for much easier maneuvering of the trailer, particularly in tight spots. Normal vehicle parking, especially in tight parking spaces, also becomes much easier with rear wheel steering. With the mode select switch in the four-wheel steer position, the front and rear wheel turn the opposite direction during low-speed maneuvers, such as parking. When the front and rear wheel turn the opposite direction, the system is operating in the negative phase. Negative phase rear wheel steering improves maneuverability while operating at low speeds.
Okay, good video there. Kind of showed you a little bit about the phases, a little bit about the modes. We saw the vehicle in action. If you haven't seen the vehicle or had the opportunity to drive one yet, hopefully that gives you a little more insight. Now, based on what you know so far, we have a question for you. It's our first calling question of the day. Let's take a look at it. And Mike, the question is, why do we use 5-degree positive phase steering versus 12 degrees negative phase? What do you think? Any ideas? Go ahead, give us a call. All right, Mike, we have Rod calling in from All American Auto. Rod, go ahead, you're live. What do you think? Why do you use 5 degrees positive versus 12 degrees negative?
I think that it'd be like more tire wearing. It'd be a where tires fast probably. Just tow in or towed out too much.
I don't know. Actually, because especially at the high speeds, we're turning both sets of wheels the same direction. It might actually reduce any scrubbing because we're trying to change the direction of the vehicle.
Right.
I don't know.
Well, let's keep trying. Yeah, we appreciate that, Rod. Let's try Steve from Foothill Ranch. Go ahead.
Hello? Hi, I wouldn't want to be doing a negative 12 degrees at higher speed. Bring the rear end around.
Yeah. That's kind of where we're headed with this. It's kind of a stability issue.
Right.
Now, definitely a problem with the microphone there. I think it's coming loose. Is that what's going on there? His site? No. Hey, you might want to just push the microphone down. We're hearing noise, I'm not sure, but it sounded like the microphone might be coming loose on. That's all about stability. You know, they test this whole thing, do the engineering, found out that 5 degrees is really about what worked best. Started going more than that, it wasn't as stable. So we want to stick with what's best there.
Yeah, we definitely would want to be doing that negative phase when traveling at higher speed. Definitely be a stability issue.
Yeah. All right. Well, I'll tell you what. Next up, we're going to talk about the 3 modes of operation. Okay. So we talked about the 3 phases. Now we're talking about the 3 modes. This is where the driver has some choices. They're asking the system to do something. Here's the 3 modes we're talking about. First off, 2-wheel steer. Conventional for steering, like we've been dealing with for years. Next up is 4-wheel steer. Conventional for steering, where we added in rear wheel steer. And then finally, we have 4-wheel steer tow. Conventional front steering with rear wheel steering that's been optimized for towing. We'll be talking more about that as we move along. So our steering angles will be based on a couple of different things. First off, mode that's selected by the driver, and then the speed of the vehicle. So we take those 2 together. Okay? Use both pieces of information to make those decisions on what's going to be done with the rear wheels. More information on modes of operation we covered a little bit later in our broadcast today. Right now, we've got a video to take a look at. It starts to take a look at some of the components we have in the system. It basically can describe where components are on the vehicle. So we start searching some of this stuff out. If you go in and diagnose it, you have a better idea where you need to look. Let's take a look.
Let's take a look at the rear wheel steering components and where they are located on the truck. The steering wheel position sensor is located at the base of the steering column. The mode select switch is located in the center stack of the instrument panel. The yaw rate and lateral accelerometer sensor is located beneath the front passenger seat. The vehicle speed sensor is located on the transmission housing or transfer case. The steerable rear axle is located in the same location as non-steerable rear axle, at the rear of the drive line. The difference, however, is the steerable rear axle includes quarter shafts with steering components on the ends of the quarter shafts. The rear wheel steering control module is located in underbody rear over the spare tire. The rear actuator consists of the tie rods, rear position sensor, steering gear motor, and rack and pinion boots, and is located behind and above the steerable rear axle. Finally, the rear wheel steering wiring harness is a subcomponent of the main vehicle harness.
All right, there you go. Now the placement of those components within the system. Some of these are similar to components you've seen on a vehicle, but got some differences there too. And yaw rate, lateral accelerometer, the steering position sensor, things like that. We'll be talking more about those as we move along.
Yeah, speaking of components, you also saw in the video some of the components on this rear axles. You can also see in front of us here. Well, this leads us to tech that we have for you on page 1-7. It has to do with lifting, jacking the vehicle. Now, a couple things to keep in mind. If you're using one of those old school twin posts in the ground hoists, you know, where you get that cradle that comes up and grabs the rear axle, all right, you got to make sure you don't contact the skid plate. You got to make sure you don't lift the vehicle by the actuator or the inner tie rods, okay? You got to make sure you contact it by the axle housing itself. Likewise, if you're supporting the vehicle with jack stands like we see, again, just make sure you contact the axle housing, okay? The components back there aren't designed to handle the weight of the vehicle, okay? Keep that in mind. Now, service information does call out where you can get procedures on how to lift and jack any vehicle, okay? If you take a look, or if we take a look at the screen here, we can show you where it's at. You can read that, can't you? Well, let me help out, so it's a little small. Build the vehicle, your general information, and then down here, lifting and jacking the vehicle, okay? Just in case you didn't know where to find that information, you should know.
All right, I'll tell you what, next up, we've got a quick exercise here. It's on page 188 in your participant guide. Again, we're just going to kind of fill this in here as we move right along. Now, the first one, again, doing it by letters here. Letter A. What is that? That is our steering wheel position sensor. It sits down at the base of the steering column. Same place we've had steering wheel position sensors in the past. B. That's our vehicle speed sensor. Again, been dealing with those for years. Same place as always. Tail shaft of trans, or in the transfer case, we've got a four-wheel drive. Mode select switch is C. That's on the dash. That's the driver's input into the system. D is our control module. It sits towards the back of the vehicle, well up underneath there, mounts to the frame. And finally, E is our steerable rear axle, same place the rear axle always been. And next up, yeah, another question for you. Again, call-in question. Who would call in, identify any one of the three inputs and its purpose? What are we doing here? Just a call.
Okay, we have Steve calling in from R.I. Buick. Go ahead, T.R.I. Buick.
Yeah, the steering wheel position sensor, an input.
Absolutely, that is one of the three. Good deal, Steve. Hey, appreciate that. Steering wheel position sensor. Right? And also, as in the past, called hand wheel position sensor.
Now, next we have Eric calling in from Roy Robinson Chevrolet. Next input, go ahead.
That vehicle sensor definitely does know which phase to operate in.
Yeah, yep. That's kind of a good point. We can kind of talk a little bit about what we're using those for as well. So the steering position sensor is telling us what direction we're turning the wheel and how far we're turning the steering wheel. Obviously, that's going to have something to do with how far we turn the rear wheel in the direction.
That's probably pretty important for the module to know.
Yeah, I think so.
In the scheme of things. So, and then we got the vehicle speed, because we got that 45-mile-an-hour cutoff, so we have to use vehicle speed for that input.
You bet.
And our last one, let's try Mark at Duke Chevrolet. Mark, what do you think?
The yaw rate sensor.
No, it's
The
a
last
good,
one would be the yaw rate sensor.
it's a good point. The yaw rate sensor, it is an input into our module, okay? But it really doesn't have a whole lot to do with the operation of the system. We'll get into a little bit more of that as we move along. So you're absolutely right, it is an input into the system. But we're looking for just a little bit different there.
Yeah, there's three of them that definitely have higher priority than all the rest, I guess, is maybe how you could say it. So thank you for calling in there. Let's try Key Pontiac Nissan with Tim. Go ahead.
Yeah, I would say the mode select switch, of course, because modules got to know whether to do which way to steer wheels or not steer them at all, depending on what the operator vehicle is looking for.
Absolutely. There we go. Driver's input into that system. Got to have that too. Good deal. Those are the ones we're looking for there. All right. Now, a couple of quick tips about the system. Think about this. GM recommends you do not use tire chains on this vehicle. Makes sense. Because when you put tire chains on, what do you do? You increase the width of the tire, you increase the height of the tire. Now, start turning it, what's going to happen? Well, with the possibility of making contact with the wheel housing. That's obviously going to cause some damage. So GM says don't do it. If it's required, if the customer has to do it, then you've got to take on that responsibility, make sure we only have in two-wheel steer. Got to keep it in two-wheel steer. That way we're not moving those rear wheels. We're not going to cause that damage. Damage occurs, it's not a warrantable situation. Okay? All right.
What about tire size?
Now, yeah, that's the other thing to really talk about is tire size. Okay? Don't change tire size on these vehicles. It's just not worth it. Okay? Too much going on there. We're dealing with the software in the module to deal with that. We're also looking at the PCM software, looking at ABS software. You got to make all three of those match. And it's just not a good idea. Overall, rear wheel steer, it's a great system to have on a vehicle, great system to not modify a vehicle with. Okay? We don't do anything to the vehicle because you can change so many things on it.
Yep, good point. Hey, Mike, we've come to the end of module number 1, so let's summarize what we covered here in this first module. Taking a look. Well, we talked the benefits of the system, okay? We talked about how we have a reduced or a smaller turning radius, and that's an important point, right?
It is.
We probably definitely keep that one in mind. Out of all the benefits, the reduced turning radius, keep that in mind for the end of the day. Next up, we also talked about the 3 phases of operation, negative, neutral, positive phase. We have a 45-mile-an-hour brake in there, kind of our transition. After that, we talked about the modes of operation. There's 3 driver selectable modes. Continuing on from there, we talk about some of the system components and their operation, and then we wrapped it up by talking about where to lift and back the vehicle and put it up in the air without doing any damage to it.
Now, if you have any questions at all during the course, please go ahead, hit those call buttons, give us a call, get those questions answered for you. And we kind of keep an eye on over there, see what's going on. We see those calls come in, we'll try and pause fairly quickly after that, take your call, and move on from there. If you don't have questions, though, it's time to move into module number 2. You would open up page 2.1, take a look at the objectives for the second module. Now, here, we're going to talk about system components and their operations. We'll start breaking it down into pieces, looking at each one, see what's going on there. We'll also talk about some of the unique system features, and then finally get some diagnostic information for this rear wheel steering system. Now, next up, we've got a video for you. This is going to get into the steering system. But pay close attention to how the mode switch operates. Okay? It's going to show you a little bit about what's going on with that. Take a look.
With mode select switch in 4-wheel steer position, the rear wheel steering control module identifies input from the steering wheel position sensor and the vehicle speed sensor. Based on the information from those sensors, the control module will react either in the negative phase, turning the rear wheels in the opposite direction of the front wheels, or in the positive phase, turning the rear wheels in the same direction as the front. The amount the rear wheels are steered in either direction is based on an algorithm programmed into the control module. This algorithm takes into consideration the mode of operation selected, the position of the steering wheel, and the vehicle speed. The control module then processes this information and turns the rear wheels. At a slow speed, the wheels turn the opposite direction, or in negative phase. At a higher speed, the wheels turn in the same direction, or in positive phase.
All right, Mike, let's get into more detailed description of each of the components, okay? Let's first start with our steering wheel position sensor. Wheel position sensor, whatever, right? Hey, let's do this. Let's take a look at where we're going to find it on the vehicle. Okay, we do have there it is on the schematic, and there it is on the vehicle. All right, and hey, we're going to find this in the same position that we would any other steering wheel position sensor on any other vehicle. Okay, but this one's a little unique. This one is a little unique. We're going to find out about that as we talk about it. Let's take a look at what it would look like if we got it for the parts department. If we got a new one in the box, we have one in the studio here, and there it is. See that pin right there? That pin is installed in a certain position. It only goes in one position. Now, where it's at right now, that is in the zeroed position, meaning it's centered. It's ready for installation, as long as the wheel's straight ahead. All right?
All right, and also, we talk about that steering wheel position center. Obviously, there's times where you're going to take a column apart to make some repair to that column. You're not going to have a shift pin, okay? Before you disassemble, make sure you got the column in the straight ahead position. Go ahead, do your disassembly, make the repair, start putting things back together. Now, if you want to put the sensor back on, you're not sure center, pretty easy to do. Just go ahead and plug in. Plug in electrically, grab Tech 2, go into the rear steer area, and take a look at the analog feedback from this sensor. Okay? There's an analog signal, there's digital signals. We want to look at the analog here. Just dial that in to see 2.5 volts. It's running for 5-volt reference, so guess what? It means that's the center position. Now, I've set it up that way. Now it's ready to go back on the steering column, have the wheel straight ahead. The other choice is you can find a paper clip or something and make sure it's slide it in. It should go right in. Now, if you take that, rotate it 180 degrees, it's not going in. It's not going to fit. It's got to be in this one exclusive location. That's 360 degrees is what I meant to say. 360 turn. 180 puts it up here. That ain't going to work.
Yeah, well, that won't work either.
Won't work either. Hey, you got to have this thing set up correctly. And then you can slide a pin in there if you'd like to do that. Otherwise, just go ahead and get slid up under the column and put everything back together. Okay? So definitely can reuse these, no problem at all.
Now, Mike, isn't it important to say that this is not like EVO sensor, okay?
It really is, yeah. It's completely different sensors put together differently, not seeing the same kinds of problem that we may have seen with some of those. Seems to be a little bit more robust, working out better.
Yeah, almost like a smart sensor compared to that old EVO type.
Yeah.
You know, definitely a little more advanced there.
We'll go ahead and talk about the signals we're actually getting, the information we're getting from the particular sensor. Okay? Really important here. Another good thing to write down somewhere. Make sure you remember this. We've got 4 signals. Total 4. We start off with analog signals. We're just hitting on there. That is our first signal. Then we get to the digitals. We have a phase A. That's our second signal. We have a phase B. That's our third signal. And then finally we have an index pulse. That's going to be our 4th signal. So, once again, 4 signals here. Coming off that one sensor. Lots of information from one source. And we can take a look at the wiring schematic next and see what's going on with that. We give a little bit better idea how this thing actually operates.
Yeah, and let's look at each one of those. Let's first start with our analog, okay? This is the analog signal, is what we're taking a look at. Now, we use 3 common circuits here. We have our 5-volt ref, okay, our source there. We have our sensor signal, and we got our low ref. Okay, so 3 circuits there that you should be pretty familiar with. But take a look at where it reports to. The steering wheel position sensor report to this is the BCN. Maybe you can tough tell there, but BCN, body control module, where the analog signal reports to. Now, the body control module takes that analog information and basically just passes it on. Check this out. Here, right here, you see class 2. It goes from the BCM to the rear wheel steer. So the rear-wheel steering control module is using this analog information, but it just takes a stop before it gets there, if you will. Okay. Let's take a look at our next graphic. Analog sensor. Okay. You said it's working on a 5-volt ref, so realistically you may see a range 3/4 of a volt up to maybe 4 3/4 of a volt. Okay. And through the travel, the steering wheel is just going to have a single rise like that. Okay. Now, remember Mike saying that if we ever lost position of this sensor, what we can do is plug the sensor into the vehicle harness. We can look at the analog signal on the tach too. If we do that, 2.5 volts tells us it's in the center position. And this just kind of follows up on that, okay? 2.5 volt in the left column there, if you draw that line over, you do see that it intersects the 0 position. Well, Mike, now that we know about our analog input, would you like to tell us about the digital?
Absolutely. Again, we got 3 digital inputs here. Let's go take a look at the wiring for that setup. You go right there. Okay? These are our digital signals. Look at the analog, now dealing with digital. We have phase A, phase B, and index pulse. Okay? Those signals sent out from the steering wheel position sensor and going to the rear wheel steering module. Okay? The input to the module. Now, let's go ahead and take a look at the actual signal here. And this next graphic shows us square waves. Makes sense. Digital signal's got to be square wave. Now, I'll start off down here with our index pulse. And it says it's got to be within 20 degrees of our center. Okay? This is our center right here. It's 0. So it's got to be within 20 degrees. What does that mean? 10 degrees either side of center. 10 degrees is not a lot, so you've got to be fairly close to that center point. And that's used for several different purposes. Use that for changing mode. We'll be talking about that as we move along. So again, 10 degrees is important. Now, we're going to use that along with other signals to help us understand exactly when a system is straight ahead. Okay, from there, moving on to B here. You look B, square wave, but you can see twice the width there at the exact center point. Another clue for module, letting it know we're getting really, really close. And signal A should go in the low position. All 3 of those happen. You are sent up. Front wheels are straight ahead. All right, now we also want to take a look at a wiring diagram here. Our overhead, and see what's going on with that. And we'll, not a little, we can see a little bit more, but this kind of shows you again that rear wheel steering control module here is got all the inputs for the digital signals. Okay, all digital signals are coming in there. So that's rear wheel steer, and you can see all 3 signals coming in. Got the marker pulse, position A and position B, all reporting directly into the module. But beyond that, we also have 12-volt signal come in. And we've got a ground circuit. Goes down to G203. Those are additional inputs that we start seeing in 2003. So 2002 vehicle is going to be a little bit different. It's not going to have those 2 leads.
So 2002, could we just simply say that it doesn't have these 2?
Yep. So you're going to be down to 6 wires in that. That's a quick way to tell the difference. Make sure the parts department giving you the right part if you do have to replace one of these.
And 03 has these 2 additional circuits.
We're looking at 8 wires.
Okay.
All right. And again, the difference that you're talking about with the analog signal, it's just going to be routed a little bit differently. 02, and we're routing it directly to the module. 03, it goes through class 2 there.
Through the BCM vehicle class 2, yeah.
Yep.
Just takes that stuff.
Yeah. Sharing that information around.
And you know, while we're talking about the steering wheel position sensor, there's a few PIs and bulletins that we want to share with you. Okay, and these are all related, Quadrasteer and specifically, a couple of them here are specific to the steering wheel position sensor. So let's do this. Let's take a look at those here. Our first one is PI 00196. Now the concern for this one is, or the concern you may encounter, is a C0550. 550 is an internal module fault, but before you just automatically start pulling a new box this thing, this tells us there is a fuse they wanted to inspect for. Okay, this thing is powered by a 125 amp mega fuse, and that's what it says right there, 125 amp mega fuse. It's under the hood. Now if that fuse is blown, you may get a C0550 code. So they want you to inspect the fuse and also make sure that it is securely torqued, because it is a bolted type fuse.
Well, I think it's huge, huh?
Well, that's
125 amps.
Yeah, that's a monster. That's a monster. So we got that one, okay, for a C0550. Now next up, here's bulletin 05, 02, 118, 001. Now this deals again with Quadrasteer equipped vehicles, and condition is that some customers may have an intermittent service four-wheel steer message, and they may also see all 3 of the indicator lights and mode switch illuminated. Okay? Now it says right here, correction, do not replace the rear steer control module. Engineering is currently working to develop and validate software fix for the concern. Temporary solution, cycle the ignition off and then on, and as it's cycled, the DTC should not reset. Okay, now there's that one. Let's look at this other one here, PIT 357C. Okay, this is fairly recent, December 13, 2004. Now, this is if you have a code specific to the hand wheel position sensor, steering wheel position sensor, which would be a C0455. If you have a C0455 and it's due to the customer, the way that their driving habits is, specifically what can happen is, again, they start the vehicle and they immediately start rotating the steering wheel before the rear steering control module has time to initialize with the other module on the bus. So it sets the code and it'll also shut the system down. All right? Now, if customer cycles the ignition key, chances are, as long as they're not ripping on that wheel immediately again when they start it up, the vehicle will be fine. Okay? It just has to do with the rotating wheel too soon here. And the fix for this is just to reflash the body control module. Use TID programming, reflash that BCM, and it should correct condition. And one final one here. Let's take a look at the last one here. Another PI, PI 01736. And here again, if you encounter the C0455 trouble code, you may want to look this up, okay? And it has to do with grounds. There's a few grounds that could be at fault causing the 455, okay? G203, D107, and D104. 3 grounds, let's say it down there, 3 grounds that could be causing the issues there, okay, of that 455 code. So, I guess the point being, like, before you really start throwing any parts at these quads or equipped vehicles, do your PI bulletin search, because there may be a situation out there that that everyone is familiar with, and they populated the system with it.
Yep, nice simple fixes too.
Yeah.
Quick and easy.
Let's keep moving along here. We've got another question for you on your keypads. This one's question number 3. All right, what is this steering wheel position sensor at its installation? Is it at molded installation? B, it's pre-indexed. C, it's color-coded mounting. Or D, alignment of screw holes. All right, there we go, Mike. Let's take a look at our results. Everyone's doing a good job. It's pre-indexed. It has that shipping pin installed in it.
That's it. Got to line that thing up. You don't have a shipping pin, just set it at 2.5 volt mark before you install it on the counter. All right, just in case there's a smart aleck in your shop. It's hard to believe, but, you know, sees it on your bench, pulls the pin, get a twist for you. We can still use
I think of a few people around here I'd like to pull that pin on.
it. Yeah.
All right, what's next?
Next up, we're going to talk about mode select switch. And we've introduced you to that. Now we want to go ahead and take a look at the electrical schematic, talk a little bit about what's going on with that thing. Here it is, momentary contact switch. That's all it is. Right? We've used lots of these. So take a 5-volt ref, come out of the rear steer module. Send it up to the switch itself in the normal position. In other words, don't have your finger on that button. We're going to a 2K ohm resistor and sending a signal back to the module. So we're dropping that voltage. Module looks at the voltage. 2K ohm resistor is going to be about 1.8 to 2.2 K ohms. It's got a little bit of a range, like most resistors do. Well, what happens here when we bring that second switch, or the second resistor in line here? We've got our 2K ohm resistor. Then we bring the 660 K ohm resistor by closing the switch, and that's going to be in parallel. Okay, when you get 2 resistors in parallel, you can do all fancy math and figure out exactly what it ought to be. But basic rule here is 2 resistors in parallel, total resistance is going to be less than either one of the resistors. And in this case, we should be in that 450 to about 550 range. Okay, 450 to 550 ohms with the button pushed. Contactor closed. So that's going to change your voltage a little bit there, obviously. Okay? That kind of a change is going to be a fairly drastic change in the voltage signal. Our normal readings there are going to be 0.49 volts up to about 4.2 volts. So obviously, 5-volt ref, we've got to have a range on either side of it to detect problems with the circuit. Goes too low, we got a problem. Goes too high, we know we got a problem. Okay? So the module is looking for a specific voltage drop, depending on if the switch is pressed or released. Now we also have DTC, and that is B3593. That is a mode switch circuit malfunction. Anytime we go outside that range, that 0.49 to 4.2 volt, this is the DTC should set. All right, well, we're going to keep going with the information on the contact switch here. The position of the mode select switch determines which steering mode we're actually going to be in here, okay? And that's the driver's input into the system. I'll go ahead and take a look at another video here to give you a little bit more detail about what's going on there.
With mode select switch in the 2-wheel steer position, the rear wheels are locked in the straight ahead position, and the vehicle steers and operates in the same manner as a normal 2-wheel steering vehicle. This normal 2-wheel steering is also called neutral phase. The rear wheels do not move relative to front wheels. With the mode select switch in the 4-wheel steer position, the system will operate in the negative phase at low speeds, turning the rear wheels in the opposite direction of the front wheels, or in the positive phase at high speed, turning the rear wheels in the same direction as the front wheels. Both operations, negative phase and positive phase, are determined by the control module and are based on the position of the steering wheel and speed of the vehicle. The resulting amount or degrees the rear wheels are turned is determined by the algorithm that's programmed into the control module. In the positive phase, this amount could be as high as 5 degrees with the vehicle traveling at higher speeds, or as high as 12 degrees when the system is being controlled by Tech 2 in the shop. With the mode select switch in the four-wheel steer tow mode, the system works essentially the same as in four-wheel steer, except that the system is optimized for towing a trailer.
Okay, well, I talked a little bit about the tow mode, but you know, we want to ask you some more questions about the tow mode. And we really haven't given you the answer to the question yet, but we want to get you to think, okay, let's take a look at it. There it comes. All right, what's the main difference between four-wheel steer mode and four-wheel steer tow mode? Now, we know it's optimized for towing, okay? We know that much. But we'll give you a couple hints, okay? We're still using negative, neutral, and positive phase. We're still going to turn the wheel 12 degrees in negative phase and 5 degrees in the positive phase. So we're not turning wheels any more or any less. So now that you know that, what do you think is occurring differently? Go ahead, just call. All right, hey, let's try Steve at Tri-Buick. Steve, go ahead, you're live.
When you're towing a trailer, it's probably when you're going in reverse, to give it more maneuverability of backing up, or when you're towing, you don't have an inch swing when you're changing lanes.
Well, it's interesting you bring it up. We're in reverse. This system actually is going to be limited to 5 degrees.
No matter what mode.
No matter what mode, yeah. Even if you're going 50 miles an hour in reverse, still only going to get 5 degrees, right? So, no, that's a good thought. No, not actually what we're doing for that tow mode here.
All right, hey, thank you, Steve. Let's keep trying. Let's try Eric at Eric calling in from Roy Robinson.
Does it change the rate? Does it change the rate of the how fast the rear wheel steers for more stability?
That's a good thought. Does it change how fast we move those wheels? No, it really doesn't do that. It's going to move the wheels. The motor operates at one speed. So we're going to move the wheels from one position to another at about the same rate. That's not going to change at all.
Okay, next we have Cody. Cody, go ahead.
It changes phase at lower speeds.
There we go. That's what we're looking for. Kind of simple, kind of straightforward. We're going to change the speed where we go from negative to neutral and then to positive. Okay, remember before we were talking about 45 miles an hour, so we're going to make that crossover. That's going to change. Now it's going to be 25 miles an hour. Let's go ahead and take a look at our next graph, kind of show you exactly what we're talking about there. Okay? Again, before we made a switch, 45 miles an hour. That's just for standard four-wheel steer. Now we're in tow mode. Okay, this is tow mode. Now in the tow mode, still got 12 degrees here. That's our negative phase. But you see very rapidly from that 12 degrees very low speed, we're going to be dumping that turn radius off. Okay, so by the time we get to this 25 miles an hour here, we're back to 0. Then we'll cross over into the positive phase. Still have 5 degrees here. Okay, so the amount that we're turning the rear wheels really hasn't changed at all. Just where we make the transition. Okay, that's going to change. 25 miles an hour instead of 45 miles an hour. All right.
Now, we should also mention about our steering wheel being slightly offset, right? We're going to talk about that.
Could happen.
I've said that a lot of times, and I don't know if I buy it.
I kind of agree. I mean,
But-
it's so small.
But, we may test them on it later, so I guess it's an important point, right? So
It
we
is.
probably cover it. Now, basically what Delphi Engineering is telling us that when we're in the tow mode, the four-wheel steer tow mode, that we may see our steering wheel offset slightly, okay? They're telling us plus or minus 5 degrees. So that's definitely an important point that you want to remember. Okay, plus or minus 5 degrees may be off, it may not, but you should probably be aware of in case you get a customer who comes in and thinks they have a alignment issue.
If it only happens in four-wheel steer, it's don't have to switch up.
Right.
It's not a problem. Don't sweat it. And 5 degrees is so small. It really is.
Yeah.
They're paying far too much attention to the steering wheel, not near enough attention to the road.
No doubt. Now, let's talk about changing modes. Now, if we change a mode, we lean over, we press the mode select switch on the IP. Before the next mode that we chose is going to engage and lock in, there's certain criteria that has to be met, okay? And if we take a look at our next graphic here, there we see the mode select switch, that's for sure, okay? And there's the one we're looking for. They're 10 degrees either side of center. Remember when Mike was talking to us about that marker pulse? Well, this is where it comes into play. Before the system is going to allow us to lock into the next mode, we have to pass through 10 degrees either side of center, just right inside that V, if you will. Because think about it, folks. If you're driving down the road, you're in one of those horseshoe-type turns. All right, you're halfway into a turn like that. You got the wheel rotated to 180 degrees. You don't want somebody to lean over, changing the mode on you, and then those rear wheels change your position all of a sudden because they can really change things in a big hurry. And it's definitely something we want to try and avoid.
Would be a wild ride, wouldn't
Yeah,
it?
it would. It would.
Check out those cattails down there.
Yeah. Yeah.
I can just see some kid doing that, too. Your 6-year-old reads over and says, "What's that do, Dad?"
Yeah.
Go flying.
I don't have kids. Now, let's take a look at our mode select switch. Okay. Here we see the mode select switch. We see all 3 lamps illuminated. Now, we have a tech tip list for you on page 2-8, so take a look at that while I describe this for you. Basically, if you ever see a situation where all 3 of those lamps are illuminated like this, This is telling you a couple things. This is telling you that maybe someone started doing alignment, but they hadn't completed it successfully. Okay? That's one thing. They've started to do the alignment, which means they plug the Tech 2 into the vehicle, and they clear all the learned parameters from the control module. But they didn't do the back half of it correctly. Now, we are going to talk all about the alignment guidelines and procedures in Module 3 today. So don't worry, we're not going to leave you hanging there. Now, one of the other ways that you may see this lamp or all three of those lamps illuminated like that is if you replace the control module. If you replace a rear steer control module and it's not programmed, okay, it's dumb coming off the shelf, so to speak. If you didn't program it and you plug it in, try to fire up the vehicle, you may see those lamps illuminated like that either. So in either case, Mike, I guess it's kind of telling us that we're not done yet. Whatever we're doing, we're just not done. Whether it's an alignment or whether it's a control module replacement, if we see those three lamps on, we've got more work to do.
Yeah. Like Andrew said, we're going to be talking about that whole process. It's not all that complicated. I think you'd be pretty surprised. There are two parts. You got to go through and set the vehicle up on the rack. Okay? Check your angles. You not have to make adjustments. Then we have to go through the electrical portion of alignment. So two portions of alignment, they really fit together. You got to do it together. Oh, there's no separating those two. Now, a couple other points about the system. If we put the vehicle in neutral, after 4 seconds, it is going to revert to wheel steer. Okay? It's going to do that. Now, the reason for that is to accommodate the car washes. That way, so you're going through the car wash, get out to the end, you want to go ahead and start turning. Hey, if it's 4-wheel steer, what's going to happen? Could pop out of the end of the track there, cause some damage to the vehicle, track, nose. So again, just kind of a safety issue. We're going to leave in 2-wheel steer anytime it's been neutral for more than 4 seconds. As soon as you put that back in gear, then we go ahead and go back to the 4-wheel steer, if that's what was selected. What are the modes selected? Now, another big point here is if we talk about putting the vehicle in park reverse. Park reverse is going to be limited to 5 degrees. Okay? 5 degrees is the max turn you can see on the rear wheels. So you may notice that as you're checking the system out here. Okay?
All right, Mike, time for another question. Another question. Okay, this is on keypad number 4. Let's take a look at it. The mode select switch lamps are all illuminated. Should you A, replace the indicator, B, the vehicle's in 4-wheel tow mode, C, mode's changing, or D, perform the alignment procedure? Hey, there you have it. D is the best possible choice, all right? You need to perform the learn alignment procedure. Hey, just because you see those lamps on, that means it's working. So you definitely shouldn't be replacing it.
All right, well, moving on here. Next thing we'll talk about is that rate lateral accelerometer. Now, unlike the other vehicles you may have seen those types of devices on, those types of sensors, this is one unit. It's combined into one. Now, starting in the 04 model year, unlimited, it's on. You'll see it on some, you won't see it on others. 02, 03, it'll be there. 04, 05, it's on. Okay? Keep that in mind. Let's go ahead and talk about the sensor a little bit. Where is it? Well, it's going to be mounted underneath the driver's seat. You can see it right there. Pull the carpeting back a little bit. You can have a look at it. So we got one combined sensor here. Now, if we take a look at the electrical wiring for this thing, you see, once again, we're dealing with 5-volt F. Okay? Coming out of that steering control module, supplying the system. We also have a low rubber return line there, and then we have our 2 signals. Now, both these signals at rest should be 2.5 volts. Okay? Both of them should be 2.5 volts at rest. Again, this sensor really doesn't do much for the rear wheel steering system. It just reported to that module. That module put that information out on class 2 to be used as necessary. So, why are we even telling you about it? Well, if you have to replace the sensor, you got to go through a centering procedure, an alignment procedure. Well, the way to do that is with the Tech 2. Okay? And if you're using Tech 2, you got to get into the rear steer area, center the lateral accelerometer portion of that sensor, zero out the settings, and learn the center position. So again, that's why we're letting you know about it here in this course. It reports to the rear steer module.
Okay, hey, move along. Let's do this. Again, if you have any questions on anything we've covered, okay, we want to make sure that you're up to speed and you feel confident with what we're talking about before we move on too far. So definitely, if you do have a question, go ahead, press your button and call in with it, okay? In the meantime here, if you take a look on page 2-10 in your book, we're going to talk about vehicle speed. Now, you know why we need vehicle speed. We need to use it to determine what phase we're going to operate in, all right? Negative, neutral, positive, okay? Now, where do we pick up vehicle speed? That's the question. Let's take a look at this graphic here, and it's going to show us. We pick up vehicle speed from every other place, or the same place that every other module in the vehicle picks up from. Our powertrain control module, okay? Check it out. IPC gets it from there. Cruise control gets it from there. So does rear wheel steer. Now, if you look at this graphic closely, you may notice that there's actually 2 inputs going in rear wheel steer. Look at this. You got this one from PCM. That's vehicle speed. You also have this class 2 one. That's vehicle speed 2. Well, one of these inputs is a discrete input, or I guess you'd call it hardwired input, where it shares the vehicle speed information. And then we also get a class 2 on this circuit. Now, if these 2 vehicle speed circuits don't match up or correlate pretty specifically, what's going to happen? Well, the rear wheel steer module is going to flag a DTC. All right, DTC, what is it? C, that's right, C0000. If you see that code, which is a pretty unique code, I've never seen it before, and you look it up, it does talk about a vehicle speed mismatch. Vehicle speed mismatch, okay? That's what that's all about. But for today's purposes, you really need to know that we do get that vehicle speed information from the powertrain control module.
All right. Well, tell you what, any questions, again, please give us a call. Let's get those questions answered for you. Next thing we want to do, though, is move on and take a look at some of the other components. What components do we add into this rear axle to make it steerable? And obviously, got to have some hard parts to do exactly that. And I don't see any calls coming in, so let's go ahead and take a look at these. Now, first off, what do we got? Well, we've got ball joints here. See those upper and lower ball joints. Definitely different. And we've got spindle in between those two. Now, on the outer edge there, we've all got wheel bearing. Again, not typical. It's very much like our front drive wheel bearing. Same idea there. We've also got to have a quarter shaft. They call it a quarter shaft because it only has one universal joint in it. And it's pretty well protected. It's there, in there you can see. Okay? What else we got? Well, we have tie rods. Okay? You can see. We got an outer tie rod here. As we start to move inward, we'll be able to see that we have an inner tie rod as well. Okay? Inside of the inner tie rod, now we get to the actuator. And the actuator's got motor assembly. Also, see all the assembly right here is part of the rear cover for our differential. Okay? So, if you have to replace the actuator assembly, you're going to be unbolting the rear cover to do that. You're going to be plugging wiring, taking off our tie rod at the outer edge there, and then moving the whole assembly out of there. All right? So, some neat features there. Now, quickly about the axle itself. It's a Dana 9 3/4-inch axle, pretty heavy duty. It uses a synthetic fluid. Okay? Synthetic fluid. Now, with that fluid, there's no change interval. Don't need it. Okay? No change interval. But if you had to drain fluid out of this thing, they do give us a drain plug down at the bottom. You're going to have to pull the shield off if it has one, and then pull that plug out and drain it out. Of course, we've got a typical fill plug on the side where it's spec. That's how you can pull it back up. So to drain that fluid out, pull it back up, you don't even have to take the cover off at all. So you don't have to deal with any of this. Now, it is a synthetic fluid. There is a specific part number for that, and you should look that up in the parts department. Now, that synthetic fluid already has the modifier, the friction modifier added into it. So it's nothing to add, just pour it in, takes out 3 of those containers to fill things up here. Okay?
But it is a specific.
It is.
It is specific for this Quadrasteer system.
Yeah, we got that on the overhead right now. Take a quick look. There it is. Quadrasteer synthetic axle gear lubricant. So definitely what you want to use. You don't need to use regular fluid at all.
All right, Mike spoke a little bit about the quarter shaft here, and that's where we want to go next. So, again, no more calls coming in, so let's do this. Let's take a look at a short animation of the quarter shaft, then we're going to come back and tell you some additional things to keep in mind.
Quarter shaft operation parallels what we've seen on other axle shafts that are a constant velocity or CV joint. The rear axle quarter shaft knuckle joints are able to move independent of one another. This allows for individual quarter shaft movement, though due to mechanical constraint, only normal axle rotation and steer of the wheels at CV joint is allowed. On a practical level, there is no camber or caster adjustment. The only adjustment is for toe.
All right, hey, there you have it, okay? That was the quarter shaft. You got an idea where it's at, okay? And now we want to tell you some additional things about it. Now, if you take a look on, page 212 in your participant guide, you can follow along with us here. Now, here you see we got the quarter shaft, got a part disassembled here for you. Now, when everything is assembled, we got our spindle and everything in place here. Realistically, you're only going to see this kind of movement, 12 degrees is not that much. Now, even at its most extreme like this, look at it. You can barely get my finger in there. Well, it's pretty well protected, folks, okay? They've taken this into consideration, that it is a truck, it's going to be seen some off-road use and whatnot, severe duty. So, it is pretty well protected in that rubber boot, and it's a perfect picture right there, okay? Barely enough room to even get anything in there, okay? Now, let's take it out of its position here, and let's talk about a couple of seals and whatnot. Here you see it, I'm going to set it down the bench, get the tie rod out of the way. And you see, conventional technology here, okay, nothing new. We got our constant velocity joint. Now, we still got a rubber boot in there, and there you get a good look at it. But look at the way that this thing's manufactured. This gold portion is like pressed on, okay? You just simply can't remove it. So look at that. You may wonder, how do I service that boot right there? How do I replace the boot? Guess what? Don't, okay? If that boot has a rip or a tear in it, you got to replace the whole unit, the whole quarter shaft. Comes with a new CD boot right there. Now, we want to talk about a couple of seals. Now, we know that we no longer have a conventional wheel bearing, do we? No longer do we have wheel bearing out here. And again, we got that integral wheel bearing out here. So we no longer have our rollers back here, which means we no longer need to supply lubricant down the axle shaft, lubricate outer bearing. So I'll tell you what, let's put our oil seal right there. Let me grab it. Where's that? Here we go. Look at that. That's where our oil seal rides. Right there in the axle housing, right there on the polished portion of the shaft. Here are the spines. You get an idea where it's at. It's going to keep all axle fluid from this point inwards. Okay? Now, there's that seal. It's a pretty unique seal. We're going to take a closer look at here in just a moment. It's like a two-piece seal. It's got 3 sealing surfaces. Let's keep looking at some other things here. There's one more seal we got to talk about. Rides right here, right on that boss. You're going to find it at the outermost edge of the housing, up here. All right? And it's just like a, we call it a grease seal for a disc brake rotor, okay? It's just here to keep, water, debris, dirt, here to keep all this stuff out of the housing. Now, one final thing I'll tell you about this. Mike did tell us the Dane axle. How do we hold the axle shaft in place? C-clip, just like other Dane axles. All right? Just kind of goes on there.
So there's a situation where you have to pull that whole unit off if you go out there and pull that axle out for some reason, huh?
Yeah, unfortunately. Now, Mike, why don't we take a closer look at these 2 seals?
All right. Well, we've got those on the overhead here. And taking a look, here is that dust seal that Andrew's just talking about. Again, kind of like grease seal, very flexible here, pops in and out, and just there to keep the major contaminants out of that tube system. Okay, press fit. All right, tap it right into place. Now, the other seal is rather unique. This is the oil seal. Kind of interesting. It's got a beveled edge here. Okay, this is the leading edge. This is where the axle shaft will be coming in. Now, if you're trying to reinstall the axle shaft, obviously, it's a long way in. So it's important to keep rotating the axle shaft. So, as you're coming in this way, if you rotate the shaft, what's going to happen? It's going to walk right at that beveled edge and slide into place for you without causing any damage. Otherwise, trying to push it through there, it just doesn't work well. So, on this particular stop, we're going to have 3 separate seals here. Obviously, we're going to have a seal on the inside. That's going to seal against the axle shaft itself. We set this thing up. Another seal on the outer edge. Seals to the housing. And then, these being 2 separate pieces, we got a seal in between the 2 of them. And what that does, it allows this inner portion here to turn with the axle shaft. Okay? We can turn that. Ours is a little bit stiff because, guess what? Never had any looking on it. The outer portion stays steady. The inner portion is going to rotate with the axle shaft. Now, it does appear that this is a pretty good deal. I haven't heard about any problems on this. Last time we asked, warranty was saying, nope, not a big deal. Don't have any claim for those. So, hopefully, not something we have to go after. It is very complex. You can add that thing. We're going to have to disassemble the rear axle here. Obviously, got to pull both axle shafts out. Then, once we get all that out of the way, we can go ahead and pull those seals out from the inside. To reinstall, you need the small block V8 cam bearing installer. That's the tool we're going to use. But it sure sounds like a lot of work.
Yeah.
Hopefully, you don't have to go there.
Hey, Mike, let's do this. We've got a couple of calls. Let's see. We have Steve calling in from Pete Harkins Chevrolet. Steve, go ahead. Steve from Pete Harkness. All right, let's try, what is Barco Pontiac GMC? Hey, Mr. Underwood. Okay. Hey, Mike, got to talk about a couple more things here. We got another safety-related information here on our pinch point.
Absolutely. Let's take a look at that. Now, this is kind of similar to front steering here. You know, if these wheels are moved a little bit, we've got a straight head position. There's a bit of room up here. You can get your finger in there. So it becomes a pinch point. If that were to move, the wheels were to move a little bit, you know what? It's going to hurt. If we remove our tie rod, then this whole assembly could float a little bit on us. Okay? It could pinch, it would hurt. Second thing to think about is somebody's playing around with Tech 2. Now we can bend these wheels back and forth. Well, now you've got 45 to 1 gear ratio on that motor, and that's definitely going to hurt. You're going to be down to about 4.5 digits, okay? Definitely bad news. So it's one of those things we've got to keep an eye on. Don't put your finger in there and get nailed by that thing. Could hurt. All right.
All right, we got to talk about angles too. Only adjustable angle on the system is toe. Set toe, let it go. Another important point for you today. Can adjust camber, can't adjust caster. That's why they also recommend not to shim pinion, to try to change the pinion angle here, try to correct for any launch shutter concerns. Because if you do, you're going to have impact on camber and caster angles, which are non-adjustable. Okay, so we want to keep that in mind too. And we got the call here. Let's try Mark. Mark, we got dialed on. You may want to try to call back in, and you may have better success next time. But I see Mark trying to get a call right now, so let's do this. Let's take a break, Mike.
Yeah, I'm ready.
All right.
Kind of hot in the studio today.
Yeah, it's a warm day outside, and I don't think I got the air conditioning working yet, so...
It's not legal until the end of April, is it?
I don't know, something
No,
like that. So anyhow, let's take about 8 minutes, and we'll see you back shortly.